Hello everybody, this is Todd Frazee and this is the S60-55 CAD Assembly tutorial for the engine frame assembly. This is going to be your next level of assembly with more components, and according to our drawing, let's take a look at that. We have multiples of the same components in some cases. We have one of each of the custom parts that are made, and you should have modeled all 1, 2, 3, 4, 5 of those parts. I'm sorry, 4 parts. You're going to need the models for the S60-115, the 137, 139, and 141. We're also going to have to download from McMaster-Carr models for the bearing and some dowel pins and some screws. We are going to do the bolted version. If this was welded, you can omit the 632 bolts, but for the purpose of this class, we're going to model these as if it's bolted together and not welded. Okay, so let's go look at what we need to put this assembly together. We're here at the drawing. We need all of these models. So we're going to look at what we've got. Okay, so I've got just like our bill of material says, I got the 115, the 137, 139, 141. But I also need to download the hardware. So let's go to our drawing again, and let's just start with the bearing. So I'm going to highlight the part number for the bearing. We're going to use our trusty Control C. We're going to highlight our minimize our drawing, and then we're going to go to McMaster-Carr. Again, it's McMaster.com, and under Find, I'm going to put in the part number. Now you may need to create an account to do this. Go ahead and create an account. Doesn't mean you have to buy anything from them, but they don't want people just using their site for downloading models, and they want the potential of you buying them from you. So here we go. I've got this bearing. It's giving me a warning that they don't have enough in stock, so that they're suggesting a different bearing number. I've already looked into it. It's a lot more expensive, but it's the same geometric size, so you could swap it out. That's kind of nice that McMaster-Carr does that. We're going to go to product detail, and it gives us all our information about this bearing. That way you know how to design it, your mating part. So this is designed to press into our model. We're going to go ahead and take SolidWorks, and we're going to download it. And if you click on it and you have SolidWorks running, it should bring in the ball bearings, or I'm sorry, the bearing for you. You can even see the ball bearings inside the bearing race. Okay. All right, so, and again, I'm going to go ahead and save this off, and I'm going to change the name of it. I'm going to strip off everything except for the part number, and I'm going to save it. You're going to save it on your H drive, not where it's just defaults to download. We're going to put it in with your other model files so they're all together. Okay, and it's in an older version, which is fine. They're trying to be more compatible with people that don't have their software updated. And you go ahead and hit save, and it's going to update it to 2021 or 2020, whatever version we're using here. You can go ahead and close that model. Now let's go back to our drawing, and let's do the same thing with our next component. So I'm going to highlight that part number, and Control C. And we're going to go back to McMaster-Carr. And again, you need McMaster-Carr running on the remote machine and able to download the model directly to that machine. So now we're at some 818 stainless steel dowel pins, 1/8 inch diameter by 1/2 inch long. They come in packs of 50 for a pack of 50 for a whole $9.28. Okay. So we can also download the model from this window. So we'll go ahead and do that this time. And we open the file, And here we are is our stainless steel pin. And we're going to, again, save this in our current version. But I want to save it in a different location, so we're going to do Save As instead. And we're going to navigate to your H drive. Okay, in my case it's not an H drive, and then we'll strip off everything on the name except for the part number, because otherwise it'll be a little too long in our feature tree. And we hit save. And yes, we want to convert it to the current version. Alright, so we're going to go back to our drawing, and we have one more to do. Okay, we have the 632 screws. So we're going to highlight that last part number, Control C. We're going to go back, and we're going to go to our web browser for MasterCar. And we're going to replace the number we had there with the new one. And it takes us to our screws, which are a black oxide alloy steel hex drive flathead screw with a 632 thread, 1/2 inch long. They're $11 for a pack of 100. Okay, so we're going to download that, open it up, and here's our screw. So you didn't have to model all that. And it'll embed the part number in your assembly so you can get your quantities and bill of materials right from there. Okay, again, we're going to go to Save As. We're going to strip off the description. And we're going to save that as its part number. And we're going to go to Documents. And we're going to save it. Your H drive, I'm sorry. In my case, it's Documents. And yes, we want to convert it to the current version. Alright, so we can close those models. We're back in SolidWorks in the base software. Now we're ready to start an assembly. Okay, let's look at our drawing and let's decide up front which our first component we're going to pull in. I'm going to suggest we just bring in the base here. It's the dash 141. Everything mounts to it except for the bearings and the axle. So we're going to bring that in first, and then we'll work on some other components that mount to it. Okay, so let's bring in the 141. We're going to go to File, New. This time we're creating an assembly. Okay, and we want the 141. We're going to open it. And it's sort of not a view we'd want to be working in. It's best for the drawing, but not so much for viewing. Okay, so we're going to take that and we're going to rotate it 90 about X. That's the bottom. 90 again. 90 again. So now we have the top. We'll line up our origins. And then we're going to go to hide those origins. Okay. So this part's fixed. Again, it has the F showing it's the first feature in here. We've got our chamfer side with our bolts coming in from behind. Okay. But if we look at an isometric of this, actually not it, it's this one. There we go. So this is roughly the same orientation as the drawing that we're working from. So that helps when you're working on your assembly. All right, let's save our file. And it wants us to save the model. And yes, we're going to rebuild. And we're going to save this as the S60-55 assembly. It's revision 1. I'm sorry, revision 0. And of course, don't forget your first initial and last name. Alright, if we save it off front, then we don't have any problems with the naming convention later. Okay, so what components are we going to bring in first? Now if we look at our drawing, we've got these common pins, so there's 4 instances of them bolting this together. But with the way the tolerances are, these pins would press into the bottoms of these uprights. And then we have all these pieces going in this drive post. Okay, so I try to tackle probably the complicated first usually. So let's go with the drive post. That way when you fatigue, you get towards the end of the day, you're working on more simple stuff. All right, so let's tackle this drive post, and we're going to treat that as it's a sub-assembly and put all the components attached to it into it, and then we will attach all of that to the base plate. Okay, and then we'll do the same thing with uh, main the main post. Okay, so we're going to go back and we're going to look at zoom out a little bit, and we're going to insert a component, and we're going to insert the drive post, which is a dash 139. This component here. I'm going to open it, and we'll just stick it somewhere out in space here, and we're going to right click on it. We're going to rotate it around, and we'll look at it roughly how it would mount on the plate. Okay, so we have a bearing that goes in either side of this. So we're going to go to insert component, we're going to get that bearing. And that bearing number starts with a 571. So it's the lowest part, McMaster part number. We're going to open that. Not sure what that failure was, and here's a bearing. Okay, so now we've got a bearing floating out here with the main post. Okay, if we highlight the entire component, because there's all these little pieces inside that sub-assembly, we're going to go Control-C and Control-V. And now we have two instances of the bearing. You can see two of them over on the left, and we have two of them on the right. Okay, so now what we can go is say mate, and we're going to mate the diameter of the first bearing to the diameter of the first pocket. And it's going to assume concentric, so we'll accept that. Okay, so it's now concentric. Everything's still floating around though, so it can move. And then we're going to have it select the bottom of the counter bore, and we want to make a relationship or mate with the back of the bearing. So I'll pick on the back of the bearing. And that brings the bearing together with the base, or with the post. We'll accept that. Alright, so the bearing has a relationship with the post that the outside of it shouldn't move with the model, so I forgot to lock that in place on that mate. So it's not a problem. We just go back and well, it's typically not a problem, but because the remote button here is in our way, I'll move that down. And if you expand this, you can see the mates in order in which I did them. So we have the concentric mate followed by a coincident mate. I want to modify this concentric. Right click on it, hit edit feature, and then I can now select the lock rotation button and accept that. Now if I accept all those mates, that one bearing is now locked in place. Now this is really a sub-assembly. We got the bearings and we got these inner pieces. It's still saying it's unconstrained because I can still move the component it's inside around. Okay. All right, let's put the bearing in the opposite side. So I'm going to select mate. I'm going to select the outside of the second bearing. I'm going to rotate them all around. I'm going to select the inside of the counter bore, and it's going to pop that and pop that in place and make it concentric. But you notice it's on the wrong side in my case. Sometimes it actually is inside. And I'm going to hit lock rotation, and I'm going to save that location. And I'm going to drag the bearing over to the side I want it to be on. And now we need to make a coincident mate between the bottom of the counter bore and the back of the bearing. All right, and if we accept that, now the second bearing is positioned where it should be, pressed into that hole. Okay, so we have a shaft that goes inside that bearing, and that is a machine component called the axle. That's the 137. So we're going to close the mate command there. And we're going to do another insert component. And we're going to grab our axle, which is the 137. And we're going to bring the axle in. And just click anywhere in space. And again, I try to rotate it so it's roughly in line with where it's going to end up. Not sure what I just did there. Okay. It doesn't have to be, but I find the auto assumptions SolidWorks makes is more robust if it's at least close. So we're going to do a mate between the main cylinder and one of the bearing holes. Okay, so select mate and our two faces. Okay, and so it's assumed you want concentric. In this case, I'm not going to look rotation because it would spin inside the bearing. We'll hit accept. But it doesn't have a current location for it. All right, the nature of this, we want it centered among the subassembly. So we're going to go down, and we could use coincident to use a face, but I'm going to use the advanced mate, which is one of the most common advanced mates I use, and that's width. So we'll select width, and we want to center this with the post. So my width selection is going to be the ends of the screw. And then my tab is going to be the width of the post. Okay, and we accept that. All right, so the axle is now installed in the drive post. Okay, now the last thing we have is the pins that go on the bottom that locate it to the plate. And they press in this half and are a slip fit in the plate. Okay, so I'm going to assemble it just like I would in real life. We're going to insert components, and we're going to grab the part number that's the pin, which is the 1/8 inch pin starts with 901 on our drawing. We're going to bring in a pin. Okay. Highlight the whole thing. Use Control C and Control V to copy it. If that doesn't work, you can always load it individually. So let's rotate these pins so they're more along the axis of what we want. Okay, again, you're using the right mouse button when you select and do that. Then use the left button to drag them onto the correct side of the part we're working on. And we're going to go mate. We're going to pick cylinder, and we're going to pick one of the holes. Okay, and we're going to lock its rotation. We're going to accept that. We'll drag the pin out. We're going to look at the bottom of the pin, and we're going to make a relationship with the bottom of the pin. And you have to be careful and zoom in, and we want to actually pick the edge of the hole. Okay, because this is a cone shape if you use the drill command. And we want to make the relationship with the bottom of that pin with where it ends being that same diameter. And it brings the two parts together. Okay, so we have the steel pin sticking out, and it mates to that edge. We're going to hit accept. And yeah, for some reason our pin stayed in one place and the post came to it. All right, so let's do the same thing. We're going to do a mate between the inside cylinder in our pin. We're going to lock rotation. We're going to accept that. And then let's slide this back out a little bit. For some reason I'm getting fit screen when I press the scroll key down. Okay, so your middle button or your scroll wheel, if you press down on it, should rotate your viewing screen. We're going to make a relationship between the bottom of the pin and again the edge that makes up the end of the hole. And we'll hit accept. And accept.